I wanted to talk about problem 1282. It's an ice skater problem, and there's actually an equation that the book doesn't have that you'll need to solve this, and so I wanted just to go over it. And so you have this ice skater, and in the final case, the ice skater is modeled just as a cylinder. And so if we look at the moment of inertia, that's the key, is solving for the moment of inertia in these problems. The moment of inertia of the person afterwards, and so that their torso has a mass, we'll call it the mass final. It's just going to be the moment of inertia of their torso in the final situation. And their torso is modeled as a cylinder with radius r, height h, and the mass is the mass final. And so in this case, if you look up cylinder in your book on page 318, you get 1/2 m r squared. So it's the mass final times r squared. So you don't actually need the height. It's kind of just some extra information there. So in the final case, that's how the ice skater looks. Now the initial case is what's tricky, I think. Or trickier, rather. So the initial case, the ice skater's arms are out and they're modeled as rods, and the thing is, the rods are a distance r away from the axis of rotation. So the initial moment of inertia would be the inertia of the torso for the person initial, which is similar to when we just calculated. Keep in mind that the mass initial of the torso is less because it doesn't include the arms. And there's going to be 2 times the moment of inertia for each arm. And that's the thing that you can't find in the book. And so the moment of inertia for each arm, it's kind of ugly, and it looks like this here. So it's 1/12 the mass of the arm times the length of the arm squared. So L sub A is the length of the arm here. You got to calculate 1 for each of them, but just calculate it once and multiply by 2. Plus the mass of the arm times this combination of L divided by 2 plus the radius squared. And so this part is basically the moment of inertia about the center of mass. And this is an extra part you've got to calculate because you're moving the center of mass over a distance. If you look here, this distance is r plus LA divided by 2. And so this is actually using something called the parallel axis theorem. So if you're interested in how this works, you can look in the book and figure this out. This isn't anything that will be tested on in the final exam or anything. So if you want to, if you're interested, you can look that up. But if not, you can also just calculate it using this equation right here. This is kind of a nasty one.